fundamental identities. There's certain things that we know mean something else. And so in the as I was saying, so when we talk about identities, what an identity is it's something that means something else. It's something that's already been proven, and we know that it means a certain thing. So for example, right, we've talked already about how some of our trig functions, they have inverses of each other, right? So for example, we said that cosecant of theta is equal to 1 over sine theta, right? And we've said that secant of theta is equal to 1 over cosine of theta. What about cotangent? Cotangent of theta is equal to 1 over what? 1 over tangent of theta. So since we can do that, we've talked about how you can actually multiply this one over there and divide over. We also have those. We can say that the sine of theta is the same as 1 over cosecant of theta. Same here, I can multiply cosine over here and divide secant over, which means the cosine of theta is equal to 1 over secant theta. And, of course, the tangent of theta is equal to 1 over the cotangent of theta. All right, they all work together. These are technically called identities. All right, they are called the basic reciprocal identities. But we've talked about these before. We've talked about how all of them work with a right triangle. You guys know all of these, right? We're all good with it. Okay. So what I want to talk first about, since we already know these, is what we call the Pythagorean identities. All right, the Pythagorean identities are true every single time you say, see, use anything. So for example, anytime I have sine squared theta plus cosine squared theta, it'll always equal 1. If I have, for example, 1 plus the tangent squared theta, that will always equal secant squared theta. And the last one that sits in our Pythagorean identities is cosecant squared theta plus 1 equals cotangent squared theta. Now, oh, I just wrote that one backward. I'm sorry, you guys, fix that. I just wrote that backward. I'm so sorry. This should be cosecant and cotangent right here. My bad. This is cotangent squared theta plus 1 equals cosecant squared theta. All right, so we have these three identities. We can move these all around. So let's say I have cosine on that side, and I come up with 1 minus cosine squared somewhere. 1 minus cosine squared is going to equal sine squared. These can be manipulated and moved around. If sometime along the way I get secant squared minus tangent squared, that's going to equal 1. All right? Or if I have cosecant squared minus cotangent squared, that would equal 1. So these can be manipulated. Do I have questions? No? Not at the moment. We're doing okay. All right. So let me show you, just so we can kind of get an idea, how we are going to use these three identities, all right, in our homework today. Okay? So here is example number 1. All right, in example number 1, let's say we need to find sine theta and cosine theta given tangent theta is equal to 5 and that cosine theta is greater than 0 or positive. So first of all, the reason we have to include this piece down here is because first we already see that tangent is positive. That only happens in the first and third quadrants, right? And so cosine is positive means it has to happen in the first quadrant. So when we find our sine, that one has to be positive as well, okay? That's the only reason we have to include this sign here. This tells us whether or not sine is going to be positive or negative. All right, so now, out of our 3 trig functions we have up here, which one, because we're given tangent, which one uses tangent in its identity? The second one, right? This one uses tangent right here. So we're going to use that one in order to find sine and cosine. So here we go. Whoops, I didn't mean to move it that far. I apologize. So we are going to be using 1 plus, I'm going to write it here. This is our identity we're going to use. Squared theta equals secant squared theta. All right, so we know tangent is 5. So I'm going to replace tangent with 5. So I have 1 plus 5 squared equals secant squared. 5 squared is 25, right? So we have 1 plus 25, or 26 equals secant squared. So then to get rid of the squared on secant, I'm going to do what to both sides? Square root it. And technically, when I square root a variable, I should get plus and minus. But at the beginning, we know it's got to be positive. Okay? So we know that secant theta equals the square root of 26. That's what we just found. How does that help us find sine or cosine? What is secant? 1 over cosine, absolutely. Or if we were finding cosine, cosine theta equals 1 over secant theta. So in this case, our cosine theta is 1 over the square root of 26. All right, so we found cosine. Are we good with finding cosine? Okay, so now we're going to find sine. We're going to find sine. You can find sine 2 ways. We can use tangent, or we can use our first identity. It's up to you guys. I think maybe we'll do this. When we were using our unit circle, tangent of theta is equal to what over what? Sine over cosine. Sine over cosine. All right. And we know that tangent is 5, right? So that actually means that this equals 5. Sine over cosine equals 5. Everybody still good? All right, so I'm going to go ahead and multiply my cosine over to there. So I have sine theta equals 5 cosine theta. Are we still okay? So I've solved for sine, but I need to replace my cosine theta. What is cosine?
1 over 26.
Yeah, 1 over the square root of 26. So that means my sine theta equals 5 over the square root of 26. So I found cosine and I found sine. Rise and shine there, Brady. How you doing? All right. So we have to take what we know from the Pythagorean identities, from our inverse functions, from what we know when we were doing our unit circle to be able to find everything. Okay? All right, let's try another one. I need you guys to stay with me.
We used tan like that because tan
Was given in the problem. Okay? So I'm going to do another one that uses a different one, and we'll figure out which one to use then. Okay? So let's go with this. Here's example number 2. let's say I want to find secant and cosecant. Those are what I'm looking for. And let's say cotangent of theta equals 3 when we'll say cosine of theta is greater than 0. All right, so let's talk about what we know here. In order for cotangent to be positive, it has to be in the first or third quadrants, right? Okay? And if cosine's positive, it has to be in the first quadrant, which means when I find both of these, their signs are going to be positive. Very good. All right, so now this is our given information. Out of our 3 identities, do any of them use cotangent? The last one does, right? That one was the cotangent squared theta plus 1 equals cosecant squared theta. So we can take that 3 and plug it in here. Does everybody agree? All right, so I have 3 squared plus 1 equals cosecant squared theta. So then we get 10 equals cosecant squared theta. And then what will we do to both sides? Square root both sides. Technically it should be plus and minus, but we already determined we needed the positive, right? Okay, so we have cosecant. Sorry, somebody's phone went off. Whoop. All right, cosecant theta equals the square root of 10. So the only thing we have left to find is secant. Well, how do we do that? What do we have that we can work with? 1 over root 10 is going to give you sine. How's that going to get you cosec? We can. We can do a lot of different things. That's what I'm saying is there's more than one way to figure out what it is. All right, so one way is to go ahead and plug that into or use its inverse and plug it into the identity. Let's do it that way this time. What do you guys think? You want to try doing that, or do you want to use cotangent, for example? Or do you want to, you guys got to tell me what you want to do. Easiest way. All right. So for me, cosecant theta equals the square root of 10, right? Which actually equals 1 over sine theta. Do you agree? Okay. All right. So leaving that alone for just a second, if I had is that what I want to do? I want to find the easiest way for you guys. All right, so if I was looking for sine, for example, we know that 1 over sine theta is equal to cosecant. So I can multiply my sine over to here and divide by my square root of 10. Does everybody agree then that the sine theta would equal 1 over the square root of 10? Yes? Okay. So now, our first identity, and this is my favorite identity to use. It's the one you're going to use the most, was sine squared plus cosine squared equaled 1, right? So we have sine squared theta plus cosine squared theta equals 1. I'm going to take this and plug it in for sine. So I have 1 over the square root of 10 squared plus cosine squared theta equals 1. 1 over 10 plus cosine squared equals 1. So how am I going to get my cosine squared by itself? Subtract 1/10 to the other side. I agree. So I end up with cosine squared theta equals 9 over 10. Now what do? Square root both sides. Absolutely. And I find cosine theta equals the square root of 9 is 3, and the square root of 10 is square root 10. But what did I need to find? I need secant. How do cosine and secant go together? It's 1 over, right? So if cosine is 3 over square root 10, secant is? All right, let me try it this way. We did this all those times we were doing our triangles, and we had our cosine. You went over to secant. What did you do with your fraction? You flipped it, absolutely. That's what we're doing here. So the secant is actually the square root of 10 over 3. You guys remember doing that? Okay. You're scaring me just a little bit. All right. We need to try another one because you guys look like I've scared you, and we haven't even gotten to the second identity yet. Like, we haven't gotten to the second set.
I get like the first part, but it's like the second part, like when you're always trying to find the next one, it's just.
Okay. The first part you're fine with.
Yeah, because like you go up and you like take out one of these.
Because it's a set thing you need to do. Yeah. Right. After that, you've got to make your decision. So let me tell you, the next 3 sections are all about what you decide to do. You may decide to do something different from what Shelby decides to do, from what Alex decides. Everybody in here might approach every problem in these first 3 sections completely differently. Okay? And so that's going to be our struggle. All right? Because I can't tell you exactly this is, you do this, you do this, you do this, you do this. You know what I mean? There's not a set anything. Okay? Let's try another one. Here's example number 3. So we will do find sine theta and cosine theta. Actually, I take that back. Let's find cotangent theta. We'll change it up a little bit. And tangent theta, given cosine equals cosine theta equals 0.8, and that tangent is greater than 0. So again, what quadrant are we going to end up in? First. We're finding tangent. Did I say it wrong? I'm sorry. Yes, I want to find tangent. We're going to find sine, and we're going to find tangent. So now, our given information is cosine. So automatically, which Pythagorean identity are we going to use? Yes. All right, so we're going to go sine squared theta plus cosine squared theta, or 0.8 squared equals 1. All right. So sine squared theta equals, or not equals, plus 0.8 squared is 0.64 equals 1. Subtracting 0.64 to the other side, I get sine squared theta equals 0.36. And then we have to square root it and square root it. And sine theta equals 0.6. That's correct. 0.6. All right, so we're halfway there. So let's look at the information we have. We have sine and we have cosine. What do those have to do with tangent? Yes. Well, that works too, but Shelby just said we know that tangent equals sine over cosine, right? So we can set it up that way. We have tangent theta equals sine, which is 0.6, over cosine, which is 0.8. Well, we know we can't leave it like that. You're close. What is it? 3 over 4? Is that what you said? Yes, it is 3 over 4. which you can simplify in your calculator. You can cancel your decimals and reduce. Was that one easier? We can do that one. Okay. So the whole idea is use your trig identity first, right? Find one of the pieces that are missing, and then from what you have, decide what the easiest way to do to get the third piece out of everything you know. All right? Okay. So I want you to, when we're done today, write those three identities for sure on your card. If you want to write the reciprocal ones on your card, you're welcome to do that too. I now want to add the next set. Are you ready? This one's not that bad. These are called your co-function identities. All right, in co-function identities, if I have the sign of pi over 2 minus theta, that one equals cosine theta. That means they're interchangeable. Huh? All right. If I have cosine of pi over 2 minus theta, that's going to equal sine theta. If I have the tangent of pi over 2 minus theta, that equals cotangent, absolutely. Which means we can also do it the other way. If I do the cotangent of pi over 2 minus theta, that's going to equal tangent theta. And of course our last two, if we go ahead and do the secant of pi over 2 minus theta, that equals cosecant theta. And any guesses what the last one's going to be? Yeah. Good. Cosecant of pi over 2 minus theta equals secant theta. All right. So we've added those. We're going to add one more very quickly. These aren't too bad. These are called, so I'm going to put a little squiggle. These are called our odd and even identities. In these, it talks about whether the angle is positive or negative. So, for example, if I have the sign of a negative angle, you guys okay if I use x instead of theta? Yeah, okay. So if I say sine of negative x, that's going to equal negative sine x. I can take the negative from that angle and move it out in front. If I have the cosine of a negative angle, it's actually just positive cosine x. That negative disappears. If I have the tangent of a negative angle, I don't know what they're doing next door, but that's negative tangent of x. All right, so three more. If we have the cosecant of a negative angle, we're going to bring that negative out just like sine. Those work together. That's going to be a negative cosecant x. If I have the secant of a negative angle, that one's just going to drop out. So we just have secant x. And of course, the last one we have is cotangent. The cotangent of a negative angle is a negative cotangent x. All right, so we're actually going to take all of these we just wrote down in the next section in our homework. Okay? So, let's try one. I'm going to show you what I mean. I hope. Example number 3. Right? I'm on 3 or 4? 4. Thank you. 4. All right. Example 4. Directions are going to ask you to use identities to find to find the value of the expression. So if I gave you something like, if tangent of pi over 2 minus theta equals negative 5.32, find cotangent theta. So we have that little mess behind it, right? That goes back to the identity we had at the top of this page. Oops, all the way back up to here, where we said the tangent is equal to the cotangent. Yep. So technically, this whole piece equals cotangent. So what does my cotangent equal? Negative 5.32, exactly. All right. Okay, so let's just take that one step further. What if I had, if tangent of theta minus pi over 2, whoops, equals negative 5.32, find tangent of theta. All right, so I say that because, actually, this right here all equals the cotangent except for one problem. Tell me about inside that parenthesis. It's flipped, right? So this can really be written as the tangent of negative pi over 2 plus theta. Same thing, right? We all agree it's the same thing? Okay. So then if I rewrite this, what can I undistribute from these two terms to put in front of it? Yeah, so really I have the tangent of a negative pi over 2 minus theta, right? And in tangent land, when the negative is on the angle, what happens to the tangent? Is it become negative or does it stay positive? It becomes negative, right? So now I have a negative tangent. And how is that going to change our negative 5.32? It's going to make it positive, right? So we're combining the two rules or identities together. All right.
So we only did that because we have to find tan again?
Well, if we did cotangent, it's going to be the same thing because cotangent also becomes negative. So it's written like this. Right. It's written like this. So this means cotangent. So I probably should have done cotangent here. Right? Okay? But, right, it's the idea that you're going to be flipping them around and making it negative. Okay? That was the idea. All right. I still have 10 minutes. I don't want to, like, totally overwhelm you guys out of those rules. Here's my last example, because then I want you guys to try some things, okay? Here's my last example today. Example number 5. And then I'll decide what problems we're going to do. So in example number 5, it says use all basic identities. So when I say basic identities, it's everything you've been introduced up to now to simplify the expression. All right, and so maybe I give you something like 1 minus the cosine squared theta over sine theta. So we're going to take all of our identities we know and we're going to simplify this. That top one has a squared term on it, which means it automatically should tell you to look at your Pythagorean identities. Okay? So out of those 3 Pythagorean identities, there was one that had a cosine squared in it. That was sine squared plus cosine squared equals 1, right? Is there some way I can move this around so that it would be 1 minus cosine squared? Right, so if I subtract the cosine squared to that side, that means I have sine squared equals 1 minus cosine squared. We all agree with that? So what can I replace this top with from that identity? What did you just tell me 1 minus cosine squared equals? Sine squared, right? So our top becomes sine squared theta over sine theta. Now how can I reduce that or simplify that further? Yeah, you can cancel out one of the signs, really. This just means sine times sine over sine, so I can cancel one of them, right? So our final answer is just sine theta. Okay? What? Go ahead. You guys got to say something so I know what's going on. This part, the other ones you didn't like, but this part's okay?
I think the other one, like the example will be fine, just as long as it's like.
Yeah, the cotangent is what I should, right. Yeah, so we're putting them together. All right, so here's what I think I want to try. What? What? Okay, so it sounds like we have no issues whatsoever. All right, then what I'd like to do is let's go with, how about 1 through 21 odd? No, 1 through 21 odd. Not that many problems. Okay? One through 21 odd. And you won't need anything more than what we've put in. You won't need anything more than what we've put in your notes. So go ahead and on your card, make sure you write down your identities, your Pythagorean identities, your odd and even you're going to want to make sure you have, and of course, those ones that were the co-function identities, right? Your card is going to be completely full, so don't write too big. Yes. Okay? All right. Bless you. So do not write too big and make sure it's legible where you can